Okay, Algebra 2, Lesson 8. Part A is polynomials. A polynomial is just a simple algebraic expression. And we'll just do some examples. Let's see. And there are different kinds of them, just depending on how many terms there are. A monomial, and as I show you monomials in these other ones, we'll talk about what the expressions look like, what the terms look like. A monomial is a polynomial that has just one term. An example of this could be 3x squared. And for any polynomial, I guess we should at least write algebraic, a simple algebraic expression. Okay, and in a polynomial, each of the terms has a couple of rules. One of them is any coefficient, which is the number in front of the variable, has to be a real number, which any number on the number line. The exponents have to be whole numbers. So no fractions or decimals, no negatives. That's a whole number. And again, monomial, one term. Terms in these polynomials are always separated by a plus or a minus symbol. So there's one term. This is an indicated product. It's 3 times whatever x is squared. Okay, then a binomial has 2 terms. Like a bicycle has 2 wheels. Binomial. 2 terms. Alright, so an example of this could be, let's see, square root of 2y to the 4th power minus 9. The coefficient is a real number, the exponent is a whole number, and there's a second term. Okay, and this one is not a variable, but that's fine. That'd be like y to the 0 power. Okay, this is 2 terms, because again, terms are separated by plus or minus symbols. Separated by plus or minus. Okay, then there's a trinomial, 3 terms. Okay, and then beyond that, we do not have special names like for what's 4 terms or 5 terms or anything. They're just polynomials. The other thing to talk about in Part A is degree. The degree of a polynomial is the largest of the degrees of the terms, which means we have to talk about degree of a term. Let's do that first. Degree of a term. To find the degree of any term, you add its exponents. So it's the sum of that term's its exponents. So if a term were, let's do x squared y. Okay, when there's no number written here for an exponent for the y, it's an understood 1. So 2 plus 1. The degree of that is 3. Okay, just add the exponents. So whenever you have more than a monomial, you look at each individual term, find the degree of each of them, and then whichever one's the highest wins. That's the degree of the polynomial. So let's write degree of polynomial. Okay, and that's the largest of the degrees of the terms. I'm not sure how else to say that properly and have it shorter. The largest of the degrees of the terms in that polynomial. So I know we're kind of getting down into B, but we have a little room here. I'm going to put another example of a polynomial and then talk about the degree. So let's do, let's see, 3x to the 7th plus 2 xy to the 4th plus 17x squared. Okay, so here's a trinomial, 3 terms, 1, 2, 3. The degree of this term is 7, because you just look at there's only one exponent in there, so 7. Here we have an understood 1 plus a 4. This one is 5. And the degree of this one is just 2. Which one's highest? 7. So the degree of the polynomial was 7. We won't be doing a lot with that, but you should recognize it when you see things, like when we talk about linear equations, the degree of these is 1. And so these are called first degree equations, because 1 first. If you see that in the book or just elsewhere, you'll know what that means. So, all we're going to be doing in Part B is graphing linear equations, which we have done before. But we'll review the steps. We have a couple of examples here, and I'll give you some little tips on how to pick your x's. So your first step, if y isn't already by itself, is to solve the equation for y. After that, you make a table, you pick some nice x's, and then evaluate the expression on the other side of your equation, and then graph. So in example 1, y isn't by itself yet. We need to do that. So subtract 2x from both sides. And get in the habit of putting the x term before the constant. So negative 2x plus 6. Divide everything on both sides by 3, because we need the y all by itself. Y equals negative 2/3 x plus 2. Alright, and when you make your table, you want to pick at least 3 x's, and you want to try to pick x's that are going to fit. So, let's start with my table. I'm going to go over here. Negative 2/3 x plus 2. And then y. It'll just fit. Alright, so when I put my value for x right here, I'm going to be taking it times this fraction that has a 3 on the bottom, and I would rather not guess where to graph fractions over here. So I want that 3 to cancel, which means anything I choose for x, I would like to be a multiple of 3. And this only goes from negative 5 to 5, so I'd rather not choose negative 6 or 6 if I can help it, which means I'm going to do negative 3, 0, and then positive 3. You always want to pick at least 3. That way, if you happen to make a calculation error, hopefully it's only on one of them, you'll get a zigzag, and then you'll know something didn't turn out right, because you wouldn't get a straight line. So we have negative 2/3 times negative 3/1 plus 2. The 3's cancel. We have a negative times a negative, which is a positive 2 plus this other 2. So that's 4. Okay, negative 2/3 times 0 plus 2. Well, 0 times anything is 0. This was just 2. And then negative 2/3 times 3/1 plus 2. The 3's cancel again. This is negative 2 plus 2, 0. And you may recall, whenever you pick your x's in order, when there's a pattern to your x's, there will be a pattern to your y's as well, if it's actually going to be a straight line. Now, I have negative 3, 4. 1, 2, 3, 1, 2, 3, 4. Right there. 0, 2. That's right here. And then 3, 0. 1, 2, 3, 0. So on the x-axis. And then I take my straight edge and connect them into a nice straight line. So here we go. I know I might be off camera here, but I'll put it back in just a moment. Okay, so there we are. My nice straight line through those 3 points. And now we can move on to example 2. Again, the first step is to get y by itself. So I'll subtract x from both sides. 2y equals negative x plus 3, because again, we're getting in the habit of putting the x term first. We need 1y all by itself, so divide everything by 2. Y equals negative 1/2 x plus 3 halves. Now, I should have moved that over a little bit. Try putting the table over here again. Okay, so that out of the way. We have negative 1/2 x plus 3 halves. There. When you're doing this on your paper, you want to do this work a little more to the right so you have room for your table. Okay, now we have a fraction again. And so my first thought is, well, I want to multiply by evens so that that'll cancel. The only problem this time is then I'm adding a fraction to that, and then there I am guessing where to put the fraction again. So this time I don't want that 2 to cancel, because when I add some half to some other half, then it can become a whole number. So this time, I don't want even x's. I want odd x's. So I'm going to do negative 1, and then 1 and 3. I could have done 1, 3, 5. I'm just trying to stay closer to the middle. Okay, now I take negative 1/2 times negative 1, and I have to add 3 halves to that. Okay, so when I multiply negative 1 times negative 1/2, that's a positive 1/2, that I add to 3 halves, that's 2. Because 1/2 plus 3 halves is 4 halves. Then when I put a positive 1 in here, I have negative 1/2 that I'm adding to 3 halves. That's 2 halves, so 1. 3 halves minus 1/2, 2 halves. All right, now we'll put in 3. All right, when I multiply these, I get negative 3 halves, but then I have to add 3 halves, which is 0. That was nice. I had a pattern to my x's, and I have a pattern to my y's, so this looks good. Graph these 3 points, negative 1, 2. 1, 1, and 3, 0. And again, take your ruler, draw the line the whole way across the Cartesian system here. And there we are. There's, whoops, sorry about that noise. There's our line. That is that. Then when we get to part C, well, let's not move this yet. If you look at this equation, okay, the constant in this one is a 2. When x is 0, y equals 2. 0, 2. That is the y-intercept. It's where it crosses the y-axis. When this one, after we got it rearranged, 3 halves. Where this crosses the y-axis is 3 halves. It's about 1.5. Okay? Because again, when x is equal to 0, then we just have 3 halves. So when you have the equation written this way with y by itself, and then the equals, and then the x, then that number on the end tells you exactly where that line goes through the y-axis. the number in front of the x tells you something also. This was negative 2/3. From this point, if I go down 2, because negative 2, right 3, because that's a positive 3 down there, 1, 2, 3, I get to another point on the line. Down 2, right 3. If this were bigger, I could keep going. It's that same slope. It's like a roof pitch. Okay, it's just a consistent pattern. When this one, negative 1/2, means down 1, right 2, down 1, right 2, down 1, right 2. I could have started up here, down 1, right 2, another point on the line. This always is the case, and then we use those patterns to do this little shortcut that we're getting to in part C. Okay, so for part C, the slope-intercept method. For this, we're going to be, well, actually we've already been using it. The slope-intercept form of the equation of a line is when y is by itself. So we're just going to write that over here. Y equals, and we use mx plus b. This is actually on the front bulletin board in my room. Okay, m stands for the slope. That's your rise over run. The how far up or down, and then how far left or right. And then b is the y-intercept. Whatever that number is where the line crosses the y-axis. When we have this and we can use this pattern, you won't have to make a table anymore. You still can, but you won't need to. It'll save you some time and space. Okay, so what we're going to do is get our equations rearranged to get y by itself, just like we were doing, and then instead of making a table, we're going to use the knowledge of these patterns. Okay, so let's go ahead with example 3 here. I have a good bit of space. I might want to add something to this, but we'll come back to that. Okay, so we get y by itself, just like before. So 3y equals negative 2x plus 6. Divide everything by 3. Y equals negative 2/3 x plus 2. Okay, so according to this, it's supposed to cross the y-axis at positive 2, because it's a plus 2. So y-axis, positive 2, I am putting a point. And think about it, if you were making a table and you chose 0 for your x, y equals 2, when x equals 0. So we have that point. Then, if the slope is negative 2/3, that means from this point I just graphed, I can go down 2, right 3, place a point. And I should be able to connect those, and that'll be my line. Now, one thing to remind you, which is something I want to put up here. When you have a negative fraction, the opposite of 2/3, that's equal to negative 2 over 3, but that's also equal to positive 2 over negative 3. A negative divided by a positive gives you a negative. A positive divided by a negative gives you a negative. Okay, and again, slope. Slope is rise over run. How far up do you go, and then how far does it run? How far across do you go? Okay, so this is our slope. Slope, M stands for slope. So if negative 2 over 3 means down 2, right 3, positive 2 over negative 3, this is up 2, left 3. So I could also, from this point, go up 2, left 3. Okay, and then from this point I can go down 2, right 3, down 2, right 3, and I keep coming to other points. They make a straight line. I can connect them with my ruler, and that's that. This is actually, when you're used to it, a lot faster than needing to make a table. Okay, now example 4 already has y by itself. That was so nice. We could make a table, but we're not going to. Alright, so I look first at the end. That is minus 3. So I put a point at negative 3 on the y-axis. 1, 2, 3, right there. Now, then I look at the number in front of the x to see what the slope is. If it's a whole number, put it over 1, because you need rise over run. So we're going to go up 3, right 1. Up 3, right 1. Up 3, right 1. If I had room, I could go down 3, left 1. Because a negative divided by a negative is also a positive. So that would be equivalent. I just don't have any room to do that. But if you look at this point, from here, I can go down 3, left 1, down 3, left 1. It's the same thing. Okay, so we connect these points, and the line will be graphed. I'm not sure I have that lined up. It's pretty good. Okay. There we are. And make your line the whole way across the grid. That is all we need to do for this. We will get a lot of practice. I think we'll probably do a little more practice than what's actually in your book. But that's it.